Hello class, welcome back. Today we're going to look at section 10-6, applications of logarithms. Okay, so we briefly touched on these logarithm things and we're going to get into some more practical applications of them today. So first off, we need to start defining some things. If we see log of some number, 4 say, and that's all we see, then it is assumed that this is base 10. Even if I don't see the 10 right there, it's still base 10. And this is what's known as common log. So common log is base 10. Okay, that's basically all you're ever going to see in most applications, except for base E, which we'll get to in 10-8, which is the natural log, which log to the base E is a natural log. Okay, but today we're going to use mainly common log, which is base 10. And so if there's nothing written there, it is base 10. Okay, so let's look at a little bit of what we're going to be doing today. Okay, so suppose I need to calculate log 3.94. Okay, so there's a number of ways to do it. The best way, of course, the easiest way, is to pick up your calculator and turn it on and just push the log button. You'll notice a log button right here on the TI-30, and most calculators, if they're any kind of a more modern calculator, they're going to say log, and that's assumed to be common log or base 10 log. So just push log, type in 3.94, close parenthesis, and think I get my answer, 0.595. So, what do you do if you don't have a calculator? Well, good question. Thankfully, there's an answer to that one. If you look in the back of your book on page 812, it's got this nifty log table. And this log table, of course, is common log. It says common right at the top, which means base 10. And so you could go over here to 39 and over here to 4, and you would see your answer as 5955. So it'll take it out to 4 decimal places there for you. But for a lot of our work that we're going to be doing, yeah, I wouldn't mess with that unless you really want to look it up on your own and not use your calculator. Or if you happen to have a calculator, you can do that. Okay, but of course, that's all we used to have back in the olden days. We didn't have these good calculators. We had to actually use log tables, and they'd have books full of log tables. But anyway, now we have these, so let's use them. Okay, so now let's do some fun with logs. Let's look at something such as 4 to the 3x is equal to 7. Okay, so trying to solve this thing, I really don't have any tools for doing it per se, because I can't find a common base here between the 4 and the 7. So I'm trying to figure out what power to raise 4 to 3x that it's going to equal 7. Okay, so the easy way to solve this is with logarithms. So let's take our logarithm, take a log of both sides. So we get log of 4 to the 3x is equal to log 7. And keep in mind, you need to take the log of both sides if you're going to keep things equal. Okay, so now we know by rule number 3 of the laws of logarithms that I can bring this exponent out front. So let's do that. 3x log 4 is equal to log 7. And now it's just a matter of algebra solving for x. I can say x is equal to log 7 divided by 3 log 4. And that's an easy thing. I can punch that in my calculator. Log 7 divided by 3 times log 4. Close close parenthesis, 0.468. Okay, so we're going to be doing a lot of that today, and a lot of your homework exercises are going to have problems like this in them. So you're going to have to be able to know how to solve these. Okay, let's move on to some different type of problems. Okay, now, suppose you're given a problem, oh, I don't know, say log 313. So that is log base 3, 13. My calculator doesn't do that. It'll only do base 10 or base e, the natural log. So what to do? Well, fortunately we have the change of base formula. Change of base formula looks like this. Suppose that log a some base and x, and I need to change it to either a common log or natural log. This is equivalent to log x divided by log base b, x log base b a. Okay? So the good thing is this b right here, I can choose. I can choose any base I want. So guess what base I'm going to choose? Yeah, I'm going to choose common log because that's what my calculator will solve, common log. So there's our change of base formula. So let's apply it to this log right here. So I'll have log 13 divided by log 3. Okay? So that I can just stick in my calculator and pull out the answer of 2.335. Okay? It's quite easily done using this formula right here. Okay, but let's look at something else here. When I'm looking at a problem like this, I'm thinking, I'm taking a 3 and I'm raising it to some power, and that's going to give me a 13. Okay, so let's look at that. 3 raised to some power is equal to 13. Okay, so now I've got the same problem here that we've had in previous sections. I'm going to take, just like I did in that previous problem, take the log of both sides. Log 3x equals log 13. I can rewrite that, of course. X log 3 equals log 13. Solving for x gives me x equals log 13 divided by log 3. Oh, look. Same quotient. That's why the change base formula works, because the 3 raised to some power 13, taking log using any base you choose, will give you the same answer. Okay? So that's where this formula comes from. So we can keep that in mind. Okay, so let's do a few more problems that you're going to see in your homework today. Okay, got a clean board here. Let's look at a problem. This is problem number 21 from section 10.6. So problem 21, it gives me a 3.5 2t is equal to 60. Okay, so we're going to solve this one much like we've been solving problems in this section. We're going to take the log of both sides. So that's going to give me a 2t log 3.5 is equal to log 60. I hope you don't mind. I went ahead and did apply law number 3 of the laws of logarithms and brought that exponent out front. You should be getting familiar with that and being able to do it by now. Okay, so now solving for t, t is equal to log 60 divided by 2 log 3.5. That's all it is. And there is pretty much a correct answer. If you want to stick it in your calculator, we could pull out a 1.634-ish and some change. So there you have it. That's how you do those types of problems. All right, let's look at one more. It's got a little bit of a different twist to it. And we'll do it right here. Now we're going to work problem number 33. Okay, in this problem, we have 3y minus 1 raised to the 6th power is equal to 80. Okay, so now if I just jump right in and start taking logarithms, notice I'm going to get a log of a variable in here. That's not going to be fun to work with. So let's go ahead and do a little bit of algebra first that we've learned from the prior sections of chapter 10. And we can make it much easier to do. Okay, so first of all, let's take the 6th root of both sides. So if we do that, I take the 6th root of both sides. That's going to cancel out this 6th power here. So it'll give me a 3y minus 1 is equal to 6th root of 80. Okay. Good, still solving for y, so I'm going to add 1 to both sides. Plus 1, plus 1. This gives me a 3y is equal to, I'm going to go ahead and write this in exponent form. So that's 80 to the 1/6 power plus 1. Okay, now I'm just dividing by 3 and I'm pretty much done here. Y is equal to 80 to the 1/6 power plus 1 divided by 3. Okay, so there it is. And of course we could plug this into our mighty calculator and get a 1.025 and be real happy. Okay, so that's your homework, a couple of examples, and the rest of it in your book, you should be able to dig all the information you need out of there. See you next time. We'll do 10.7. Bye.